Hi everyone. Today we're going to talk about Chapter 19, Environmental Regulations, Hazardous Substances and Wastes. So we'll talk about how hazardous and toxic materials affect the environment. We'll talk about characterizing those materials, controlling hazardous materials and waste, managing the health risks associated with them, how they enter the environment, hazardous waste dumps and regulatory response, management choices, chemical releases, international trade in hazardous waste, and nuclear waste disposal. So let's start with hazardous and toxic materials in our environment. Our modern technology society makes use of a large number of substances that are hazardous or toxic. And in sites around the world, accidental or purposeful releases of these hazardous and toxic chemicals contaminate land, air, and water. Governments and international agencies set rules and standards to protect the health and safety of people. So here's a visual of the life cycle of toxic substances. So some are used for research and development. Those that create good products get used in manufacturing and importation. Those things are stored, transported, they get used, and eventually disposed of, right? And in any number of these steps, there may be release into the environment in some way. Hazardous substances or hazardous materials are those that can cause harm to people or the environment. Toxic materials are a narrow group of hazardous substances that are poisonous and cause death or serious injury to humans and other organisms by interfering with normal body function. Identifying hazardous materials. Different organizations and government agencies have differing definitions of what's hazardous, and the U.S. Department of Transportation lists several kinds of hazardous materials. For example, things that could be transported, right? Like you might see semis carrying things that are labeled as explosive or flammable solids, radioactive material, gases, oxidizers, corrosives, flammable liquids, poisonous materials and infectious substances, and miscellaneous dangerous goods, kind of a catch-all category there. So hazardous substances and materials are useful materials that can cause harm to humans or the environment. Hazardous wastes are byproducts of industrial, business, or household activities for which we have no use. Hazardous wastes are regulated differently from hazardous substances, and the EPA defines hazardous waste in two different ways. Characteristic wastes are those that have one or more of the following characteristics. It's ignitable, corrosive, reactive, or toxic. And listed wastes are the other type, and those are identified as being included on one of several lists. So there's more than 700 substances on lists of hazardous wastes. Hazardous wastes are byproducts, we said that already. They have to be disposed of in an appropriate manner, and there are really stringent regulations pertaining to the production, storage, and disposal of hazardous waste. So common materials can produce hazardous waste. The products we use, like plastic. Well, plastic can potentially generate organic chlorine compounds. That's hazardous waste. Pesticides can also break down into organic chlorine compounds or phosphate compounds. Medicines can break down into organic solvents and residues. Paints contain heavy metals, pigments, solvents, and organic residues. So you see there's a pattern here. You should be familiar with how some of these common items can become very problematic. In order to control hazardous materials and waste, we regulate the use of toxic and hazardous substances and the generation of toxic and hazardous waste. Most countries draw up a list of substances that have been scientifically linked to adverse or negative human health or environmental effects. So laws and regulations, U.S. governmental regulations to control hazardous materials and waste began with the creation of the Environmental Protection Agency, or the EPA, and the Occupational Safety and Health Administration, OSHA, in 1970. Many laws to control hazardous materials and waste were passed in the 70s. The Clean Air Act, the OSHA Act, Clean Water, Safe Drinking Water, Hazardous Materials, and so on. And these are really important acts that have done a lot of good to protect people and the environment. Purpose of regulation of hazardous materials and hazardous waste is to stop pollution. Regulations dealing with hazardous materials and waste must treat all parties equally. And when dealing with past pollution events, governments must assess who will pay for the cleanup of hazardous substances or waste that enter the environment. The potentially responsible party, the PRP, will have to pay for dealing with the remediation of a site once hazardous substances or waste are found in the environment. Many polluted sites were orphaned because PRP no longer existed. Voluntary standards. Some voluntary industry standards have been developed and incorporated into federal acts, like the ASTM International Phase 1 Environmental Site Assessment Standard. This is an example of a voluntary standard, which involves prior assessment before beginning a project. Groups that participate or hold themselves to the standard must conduct an environmental site assessment to determine potential environmental liabilities associated with the project. And the International Organization for Standardization has a standard for environmental management systems known as ISO 14000. Many organizations and corporations seek ISO 14000 certification as a way to indicate that they're controlling their environmental impact and improving their environmental performance. All right, let's talk about health risks now. How do we manage health risks associated with toxic substances? Well, first we need to include some vocabulary terms. Acute toxicity occurs when a person is exposed to one massive dose of a substance and becomes ill. Acute toxicity is readily apparent because organisms respond to the toxin shortly after being exposed. Chronic toxicity occurs when a person is exposed to small doses over long periods. Chronic toxicity is much harder to detect as effects may not surface for long periods of time. And synergism. Synergism is a situation when two or more relatively harmless individual compounds can become highly toxic and do great damage when combined. Most toxicity studies focus on a single compound, so acute or chronic. Persistent pollutants remain in the environment, essentially unchanged for long periods. Most of these persistent pollutants are human-made compounds, things like DDT or PCBs. Heavy metals are also toxic, and they're often released as a byproduct of extraction and manufacturing processes. Some examples of heavy metals are lead, mercury, arsenic, cadmium, and beryllium. Persistent pollutants can accumulate in food chains. So if you remember talking about how energy is transferred up a food chain, right? How only 10% moves its way up, right? So the higher up you eat in the food chain, the more concentrated these heavy metals become. That's why you're only supposed to eat so much fish, especially fish that are predators like tuna. You're supposed to limit your intake of those so that you don't get too much heavy metal exposure, because those things will accumulate in your body as well, right? All right, non-persistent pollutants are pollutants that do not remain in the environment for a long period. They're biodegradable. They may decompose by reacting with environmental factors. Non-persistent pollutants need to be kept below a threshold level to protect the public from acute toxicity. And non-persistent pollutants are not likely to represent a danger of chronic toxicity since they either disperse or decompose. and non-persistent pollutants do not accumulate in the food chain. A good example of a non-persistent pollutant might be something like Roundup that ends up not where it should be on the field. Roundup breaks down within a week. It breaks down into components that are harmless. So it doesn't accumulate in the food chain because usually when it's applied, it's early in the growing season. And by the time those food products are harvested, the Roundup itself is long gone. All right, setting exposure limits. Nearly all substances are toxic in sufficiently high doses. At what dose does a chemical become a hazard? Well, several government agencies publish guidelines or set exposure limits for hazardous materials in air, water, and soil. Some of the terms you'll see in this are PEL, or permissible exposure limits, STELs, short-term exposure limits, TWAs, a time-weighted average, or CL, a ceiling limit. People can be exposed in three ways or three routes of entry for the most part, either inhalation, consumption, or absorption. And each route of entry may require a specific kind of regulation. New chemicals require that their toxicity be determined, and to set an exposure limit, a regulatory agency will determine the level of exposure at which no test animals are affected. That's the threshold level. The exposure level is set lower than the threshold level to allow for a safety margin. Businesses and industries are highly regulated in how hazardous waste can enter the environment. Individual citizens are becoming more important as sources of hazardous waste releases. And hazardous waste enter the environment in several ways, including evaporation, spills, leaks, or purposeful release, like somebody dumping something, or storing it on land, improper labeling, and record keeping. So what's the regulatory response to hazardous waste dumps? Well, in the U.S., prior to the Resource Conservation and Recovery Act, or RCRA, in 1976, hazardous waste was essentially unregulated, and hazardous waste were simply buried or dumped. Sites were typically located convenient to the industry and were often in environmentally sensitive areas. Water and air were polluted by releases to air or leaching by water from hazardous waste sites. And in North America, there were more than 25,000 abandoned or uncontrolled sites. Let's talk more about RCRA. So, the U.S. RCRA Act of 1976 gave the EPA the responsibility of regulating hazardous waste, and it required that hazardous waste be identified. It created the cradle-to-grave concept of hazardous waste management by regulating generators, so the groups that are creating the hazardous waste in the first place, transporters, and treatment, storage, and disposal facilities. All participants in the chain must document their participation. All the waste has to be accounted for. Amendments added underground storage tanks and petroleum products to the regulatory function of the EPA. And over time, the regulations applied to more generators and became more stringent. The result has been a 90% reduction in hazardous waste between 1976 and 2017. Here's a nice visual of some RCRA requirements. So, let's see, here's the hazardous waste generator. It has to be documented when the transporter picks it up. It has to be documented at the storage facility. If it's moved to a treatment facility, that's documented. Any transport is documented. Storage in a secure landfill is documented, and they have to report it all back to the EPA or state agency. Several kinds of waste are specifically exempt by law from RCRA regulation. And that includes hazardous household waste, agricultural waste that's returned to the soil, mining overburden and processing waste, waste associated with oil and gas exploration and production sites, and ash from burning coal. A 2016 rule by Obama administration to regulate coal ash sites was prevented from taking full effect by the Trump administration that followed. So what I'd like you to do is pause the video right now, jot down in your notes, what do you think? Is this acceptable? How would you feel if you had to dispose of hazardous waste in a specific way? Do you think it would be worth it? Do you think there would be some challenges? Jot down your thoughts here on what you think about whether or not these things should be regulated and why or why not. All right, Comprehensive Environmental Response, Compensation, and Liability Act, CERCLA. The CERCLA was enacted in 1980, and this law defines the financing with the cleanup of large, uncontrolled, hazardous waste sites, and it became known as a Superfund. The U.S. federal government became the principal participant in the cleanup of hazardous waste sites. CERCLA has several key objectives: to set priorities for cleaning up the worst existing sites first, to make those who created the hazardous waste site, the potentially responsible parties, pay for that cleanup when possible, and to set a $1.6 billion hazardous waste trust fund, the Superfund, to support the identification and cleanup of abandoned hazard waste sites, to advance scientific and technological capabilities in hazardous waste management, treatment, and disposal. Under CERCLA, more than 44,000 sites were evaluated, and about 11,000 were considered serious enough to warrant further investigation. The list of these sites became known as the National Priorities List, and the list is still active, and the number of sites fluctuated as new sites are added and old sites are deleted as they're cleaned up. What I'd like you to do is pause this video, see if you can Google and find the National Priorities List. Are there any Superfund sites that are located near us or in Michigan? Look and see. 11,000. It's quite a lot for 50 states. CERCLA provided that anyone who contributed to a specific hazardous waste site could be required to pay for the cleanup of the entire site, regardless of the degree to which they'd contributed to the problem. Initially, many companies found it cost-effective to hire lawyers to fight their inclusion in cleanup efforts. Millions of dollars was spent on legal maneuvers and technical studies, and little cleanup occurred. Ultimate accomplishments is over 44,000 sites were evaluated. 11,000 were added to that National Priorities List. By 2019, there were about 1,300 sites remaining on the National Priorities List. That's huge. 11,000 to 2019 in about 40 years, or 11,000 to 1,300 in about 40 years. Most of the remaining sites are in the process of being cleaned up or are under study about the best way to proceed. It's cost the U.S. federal government $27 billion in total expenditures, and settlements with responsible parties provided about $35 billion. The Superfund Amendments and Reauthorization Act, or SARA, included several items, but one specific provision. If prior to the purchase of commercial real estate, a person or entity conducted an all-appropriate inquiry using good and customary practices, they would not be held responsible for the cleanup of any contamination on the property. This was known as the Innocent Landowner Defense, or ILD. It also provided additional funding. Small Business Liability Relief and the Brownfields Revitalization Act. Because CERCLA could require a new owner to pay for the cleanup of previously abandoned industrial sites, many were left vacant, and these abandoned industrial sites became known as brownfields. Developers weren't willing to accept the liability they would incur if they purchased the land for redevelopment. This new act included new language that protected purchasers from liability under CERCLA. Purchasers of commercial real estate are required to perform an ASTM Phase 1 environmental site assessment prior to purchasing the land. The act also provided funding to conduct that site assessment and planning for redevelopment. And this act has allowed many Superfund sites to be remediated and returned to a useful function. rather than to sit vacant as brownfields. All right, what are the choices with hazardous waste management? Well, the EPA promotes a pollution prevention hierarchy. First is to reduce the amount of pollution at the source, make less pollution in the first place, right? Recycle waste whenever possible, treat waste to reduce the hazard or volume, and dispose of waste on land or incinerate them as a last resort. And here's a good way to visualize that pollution prevention hierarchy. Reduce and reuse, recycle, treatment, disposal. I would draw this hierarchy out in my notes if I were you, with the different titles and then one or two good examples to go with each level. Reducing the amount of waste at the source. So pollution prevention or waste minimization encourages changes that prevent the waste from being produced in the first place. Many of these actions are simple and cost little. Prevent spills, leaks, and broken containers. Replace hazardous solvents with water. Use the waste produced on one part of the product as an input for another. Clean solvents so they can be reused, and allow water to evaporate to reduce the volume of waste needing disposal. Recycling. So recycling involves using waste for another purpose. So they're no longer really a waste, they're an input for something else. Burning waste oils and solvents as fuel is an option. Incorporating ash or other solid waste into concrete or other building materials. An acidic or basic waste may be usable by another manufacturer. Treating waste is another way to reduce the hazardous nature. So we can neutralize acids and bases. We can use natural processes to degrade things. Air stripping, carbon absorption, and precipitation. And when I say precipitation here, I'm not talking about rain and sleet and snow. Precipitation in a chemical sense. So a chemical reaction that causes something that was dissolved to come out of solution so that you have a solid in a liquid, and those are easy to physically separate. Disposal methods. Recovery and treatment activities reduce the amount of hazardous waste that needs to be disposed of by about 26%. The remaining wastes are typically incinerated or disposed of on land. The goal is to keep these things out of the water, right? Incineration or burning burns the waste at high temperatures, and a well-designed, well-run incinerator can destroy 99.9999% of hazardous materials. High costs and concerns about emissions have kept incineration from becoming a major hazardous waste disposal method in North America. Only about 3% of our hazardous waste is incinerated here. Land disposal is the primary method used in North America because abundant land is available and it's less expensive than incineration. Deep well injection is about 68% of our waste. Discharge of treated or untreated liquids into water sources is about 12%. Placement of liquid waste into surface holding areas is about 1%, and storage of solid waste, hazardous waste, in waste landfills is at 3%. Here's a different way of visualizing that same data. All right, toxic chemical releases. The Emergency Planning and Community Right to Know Act, or EPCRA, was passed in 1986. And any industrial plant that released at least 23,000 kilograms of toxic pollutants into the environment is required to file a report. These were primarily manufacturing industries, and the information collected allowed the EPA to target specific industries for enforcement action. Since the information is public, industries were encouraged to reduce their toxic releases. And from 2009 to 2018, toxic releases to the air decreased by 37%. And because of recycling, energy recovery, and treatment, only about 12% of toxic waste produced are released into the environment. Metal mining, chemical and power generation, and metal manufacturing industries together, they account for about 79% of toxic releases. You can look at this to see how that's distributed. Hazardous waste regulations in industrialized country increased the cost of disposal, and export of hazardous waste to developing countries became economically advantageous. However, often the receiving countries lacked the administrative and technological resources to safely dispose of or recycle the waste. Workers used unsafe methods that resulted in their exposure to toxins. The Basel Convention of '92 is an international agreement to control transboundary movements of hazardous waste to protect human health and the environment, specifically in those developing countries. Receiving countries must have competent organizations to manage that hazardous waste. And although most countries have approved the convention, there are still individuals or companies willing to ignore the rules. Radioactive wastes are hazardous and toxic by definition of RCRA, but are regulated in a different manner than other hazardous materials. The Nuclear Regulatory Commission, the NRC, is responsible for managing spent fuel from nuclear power plants, waste associated with the decommissioning of nuclear power plants, and low-level waste from a variety of sources. The Department of Energy has a major responsibility for the waste associated with cleaning up contaminated sites from research and weapons development. The nuclear fuel cycle involves mining uranium, processing it, using it as fuel for nuclear reactors, and then reprocessing or disposing of the spent fuel. Each of these steps in the process results in some nuclear waste, and the legacy of past nuclear research and weapons development resulted in a great deal of waste and contamination. There were thousands of contaminated sites containing hundreds of underground storage tanks, millions of 55-gallon drums of waste, and thousands of sites with contaminated soils. Several major sites have been cleaned up, and each year there are fewer sites, and those remaining are smaller. So we're making progress. Contamination from nuclear research and weapons production. So here in the U.S., nuclear research and development was initially related to the development of weapons for use during World War II. Many of the research and production facilities dealt with those hazardous chemicals and minor radioactive waste by burying them, pumping them into the ground, storing them in ponds, or releasing them into rivers. The Department of Energy has become a steward of a large number of sites that are contaminated with hazardous chemicals and radioactive materials. More than 500 sites were evaluated to determine if cleanup activities were required, and more than 100 required some level of cleanup. Dealing with the problems at contaminated sites involved packaging and disposition of hundreds of thousands of metric tons of uranium and depleted uranium. Packaging and disposition of plutonium and plutonium waste, hundreds and thousands of liters of liquid waste, packaging and disposal of hundreds of thousands of cubic meters of transuranic waste, packaging and disposal of over 1 million cubic meters of low-level radioactive waste, and remediated contaminated soils and groundwater. And the accomplishments of this are over 90 major sites have been cleaned up. 16 have continuing cleanup activities occurring. All right, contaminated nuclear sites remaining. So thankfully there are none in Michigan, but it looks like there's one not too far away from us in Ohio or New York, and they're scattered across the country here. Waste from nuclear power plants, so spent nuclear fuel or other contaminated material that's associated with that. Currently in the U.S. and many other countries, the spent fuel rods are being stored temporarily at those power plants. There are 4 general categories of nuclear waste. Transuranic wastes are highly radioactive wastes, contain a large number of atoms that are larger than uranium, with half-lives greater than 20 years. Uranium mining and milling wastes have low levels of radioactivity, but are above background levels. High-level radioactive wastes are spent fuel rods and highly radioactive materials from the reprocessing of fuel rods. Low-level radioactive wastes have low levels of radioactivity and are not classified into one of the other categories. Transuranic waste from former nuclear weapons sites is transported to the Waste Isolation Pilot Plant, or WIPP, near Carlsbad, New Mexico. This facility began accepting waste in March of 1999. And here's a picture of what WIPP looks like. Uranium mining and milling waste. And the most serious problems associated with these wastes are direct gamma radiation, dust, release of radon gas, erosion and dispersal of materials into surface water or groundwater. Waste management activities of mining and milling include building fences, putting up warning signs, establishing land use restrictions, and covering the waste with a thick layer of soil and rock to prevent erosion, windblown particles, and groundwater contamination. Here's a visual of a uranium mine tailings. So tailings are the leftover material that's left after they extract the uranium. Disposal of high-level radioactive waste is a major problem from the nuclear power industry. France, Japan, Russia, and the UK and India have spent nuclear fuel reprocessing plants. This deals with less than half of the high-level radioactive waste from power plants, and the reprocessing extracts radioactive material that can be used to manufacture new fuel rods. It reduces the volume and level of radiation and residues to allow for easier disposal. Countries that do not process spent nuclear fuel store it at the nuclear power plant. And here in the U.S., we have about 83,000 metric tons of highly radioactive spent fuel rods stored in special storage ponds at nuclear reactor sites. There is no permanent storage facility, and many plants are running out of temporary storage. Most experts feel that the best solution is to bury waste in a stable geologic formation. Countries that do not reprocess spent nuclear fuel, like ours, we temporarily store it at the power plant. There are no permanent storage facilities, and we're running out of space. Finland and Sweden have chosen sites. Canada and the UK and France are in the early stages of selecting sites, and the United States has not been able to establish a clear policy on dealing with spent fuel rods. In the U.S., we have that 83,000 metric tons of spent fuel rod waste. They're mostly in these temporary storage sites with water-filled containers. Many nuclear power plants are running out of storage space, and older spent fuel rods with lower radioactivity are stored in above-ground dry casks. So here's a storage facility for spent fuel rods. Here's an above-ground storage facility for spent fuel rods. Low-level radioactive waste disposal. So currently, the U.S. produces about 143 cubic meters of low-level radioactive waste annually. It consists of materials used in the medical field, protective clothing worn by people working with radioactive materials, contaminating cleaning materials, and materials from many other modern uses of radioactive isotopes. It's buried in disposal sites in South Carolina, Washington, Utah, and Texas. 1986 was the deadline for each state providing its own storage sites. And states formed regional compacts where one state provided a disposal site for all the states in the compact. Several states do not have a permanent disposal site for their low-level radioactive waste. There is a site in Utah that accepts low-level radioactive waste from any state. And here's a picture of low-level radioactive waste storage. All right, so in this map, active disposal sites have a red star. Gray states have an approved compact, and green states are unaffiliated. So, in summary, industrialized countries in Europe and North America began major regulation of hazardous materials only during the last 40 years. Many developing countries exercise little or no control over such substances, and there's no agreement as to what constitutes a hazardous waste. Things that burn, explode, corrode, and cause oxidation are typically included along with gases, radioactive materials, and poisons. There is a difference between acute and chronic toxicity. Toxins may also be persistent or non-persistent. RCRA established a cradle-to-grave system of dealing with hazardous waste. CERCLA established programs for cleaning up hazardous waste sites. And the primary sources of toxic releases are mining operations and electric power plants. The current strategy of the EPA is to limit the production of waste in the first place by reducing the waste at the source, recycling materials so it doesn't become waste, and treating waste to reduce its hazard or volume, and as a last resort, disposing of that waste. High-level nuclear waste is currently stored on the site of nuclear power plants, and low-level waste is stored in secured landfills at 4 sites. All right, as always, any questions you have, please bring them to class or student office hours.